Hello dear students, I hope you are fine and doing well in your studies. Students, today we are going to start from where we have finished in the previous session. Student, in this session, we will do some basic questions, examples, theorems, which are important regarding to this chapter. So, let us begin with the chapter itself. In this class, we will study domain, codomain and range. These are the basic definition of this chapter. If a function f is defined from set A to set B, then for f such that A to B, let set A contains elements A, B, C, D, it is mentioned here, and set B contains elements P, Q, R, S, T. Then what is the domain? The set A is called the domain of the function. Means all element of set A are the elements of the domain and all element of set B are the codomain of the function. Then what is the range? The set of f images of the element of A is called the range of the function. Means range of the function is only P, Q, R, S, or you can say range of the function is the subset of codomain. Means this set is codomain, this inner part is called range, and this whole set A is called domain of the function. One more concept regarding domain and range is here. Domain, all possible values of x for which fx is exist. What is the meaning of this? Let fx equals to x plus 2. Then all input, all values of x for which fx is exist, the value of x are called domain. And what is the range? Range is the value of fx at the points of domain, or you can say at the possible points of input. Then we can understand what is the domain and what is the range. Now let us see what is the equal function. Two function f and g are called equal function if and only if domain of f is equal to domain of g, codomain of f is equal to codomain of g, and fx equals to gx for the common domain. Now let us see one example. If a is given, b is given here, and function f is given from a to b, fx equals to 2x, and g is given from a to b, gx equals to x square. And you have to check the function are equal or not. As we know that this is the domain, this is the codomain, means domain and codomain are equal, means first two conditions are valid. Now fx equals to gx for the common domain. We have to find that the value of f0, it will be 2 into 0 means 0, and value of f2, it will be 2 into 2 equals to 4. Now for the function g, the value at 0 will be 0 square, it is 0, and at 2 value will be 2 square, it is 4. Now you can say all three conditions are valid. That's why function fx and gx are equal function. You can write f equals to g. Let us consider one more example. Fx is equals to x square minus 4 upon x minus 2, and gx is equal to x plus 2. You have to check the function fx and gx are equal or not. And here it is given that f is defined from r minus 2 to real number and gx is defined for r to r. As we know, the domain of both functions are not equal. That's why the function fx and gx are not equal function. If you calculate this system, then you can say x square minus 4 upon x minus 2, factorize the upper part, it is the x plus 2, x minus 2 upon x minus 2, x minus 2 is cancelled out. Then you can observe that the function is also x plus 2, but according to the domain, this function is not equals to x plus 2, and this 2x is equal to x square. This is the importance of understanding the equal function. For better understanding the basic of the chapter function, we have to understand intervals. How many types of intervals? What is the intervals? The set of numbers between any two real numbers is called interval. The following types of intervals are here: closed, open, and semi-open, or you can say semi-closed. What is the meaning of closed interval? Closed interval contains all the numbers between a and b and including a and b. You can say all the numbers x such that x greater than equals to a and less than equals to b. Equal sign is here, means terminal points are included. In open interval, terminal points are not included, means only the numbers lying between a to b are considered in open interval. X such that x greater than a and less than b are lying between open interval a to b. Now you can understand what is the meaning of semi-open or semi-closed interval. Let us study another most important topic, sign scheme, or you can say wavy curve method. This is the one of the most basic concept which is used to find domain and range of the functions. This method is used to find intervals where the expression is positive and negative. Consider the expression x minus c1, x minus c2, x minus c3, dot dot dot, x minus cn, where c1, c2, c3 are in this order. What are the basic steps of sign scheme method? Step first, you have to arrange the expression in the linear form, which is given here. Step 2, find all the critical points of the expression. How we can find the critical points? By substituting linear factor equals to 0. For example, x minus c1 equals to 0, x equals to c1. This is the critical point. Now step third, plot these points on the number line in increasing order. That is the reason the order is given here. Now step 4, check the coefficient of x and make them positive. It is one of the most important step. You have to always check this step 4. Step number 5, start the number line from right to left taking sign of expression, means from this side to this side. And step 5, check your answer should not contain a points for which function does not exist. For this example, let c1, c2, c3 are the here up to cn, and from right hand side we have to make a wave which comes from the plus infinite region, you can say, and goes to the minus infinite region, and it comes from the upper side of this number line and reaches to the largest critical point, and then goes to the second critical point, and then third, and so on up to minus infinite. One thing is, remember, if this linear expression contains odd powers like this, means here power is 1, then you can use alternate plus minus sign in the sign scheme. But it is not always happens. Suppose we are going to take an example, x square upon x minus 2. Now we have to find the reason where it is positive. Then what is the critical points? Critical points will be x minus 2 equals to 0, means x equals to 2, and from the numerator x equals to 0. Arrange the critical point on the number line in increasing order. A wave comes from the plus infinite side. Now we have to check the power of the linear factor. If it is odd, then this wave crosses the number line and goes to the next critical point. Now at this point, we have to check the power of the critical point 0. It is even. Now this wave cannot cross the number line and goes to the minus infinite direction. This is the plus infinite. Above number line region you can say plus region, and below number line region is the minus region. Then what is the answer? Answer of the positive region is 2 to infinite, means this system is always positive if x belongs to 2 to infinite, excluding 2, because as we know, denominator never be 0. Let's see an example. Find the interval in which fx is positive or negative. Fx is given here in the linear factor form. Find the critical points. X minus 1 equals to 0, x equals to 1, x minus 2 equals to 0, x minus 3 equals to 0, x equals to 3. Linear factors have odd powers, so the basic sign scheme will maintain. Now arrange the critical points number line in increasing order. What is the critical points? 1, 2, 3, means 1, 2, 3. Now waves come from this side, goes to this, and then crosses it, and then goes to this side, and so on. This region is the plus region, which is above the x-axis, you can say, above the number line, and this region is the minus region. Now for positive nature of fx, interval 1 to 2 and 3 to infinite. So you can say fx is greater than 0 for x belongs to 1 to 2 union 3 to infinite, and fx is negative for the negative reason, and you can say x belongs to minus infinite to 1 union 2 to 3. Let us see what is the real function and real valued function. A function whose domain and range both are subset of real number is called the real function. And if a function f is defined such that from set A to set B, that B is the real number, or you can say subset of a real number, then function f is called real valued function. This is the basic difference. Means in real function both are the real number or subset of a real number, but in real valued function only B should be either real number or subset of a real number. Now we are going to study value of the function. If y equals to fx is any function defined in real number, then for any given values of x, say x equals to a, the value of the function can be obtained by substituting x equals to a in it, and it is denoted by fa. Two examples are given here. If fx is equal to x square minus x plus 1, then find f0 and f2. What is the value of f0? We have to put x equals to 0. It is the 0 square minus 0 plus 1 equals to 1, means f0 is 1. And what is the f2? f2 will be 2 square minus 2 plus 1. Solve it out. 4 minus 2 plus 1 is equals to 3. Now in this question fx is given and you have to find f0. What is the f0? f0 will be 0 square plus 1 upon 0 minus 2. It will be minus 1 by 2. And what is the f1? f1 will be 1 square plus 1 upon 1 minus 2. It is minus 2. And what is the f2? f2 will be x square means 2 square plus 1 upon 2 minus 2. It is does not exist, or you can say not defined. So value of function can be obtained by substituting the value of x in the given function. Now we will study domain of the real function. According to the different function, domain can be different. Let a function of the type 1 upon fx. Domain can be defined for this system all real number except the point where fx is equals to 0. This is the type first. Type 2. What is the domain of a category root fx? Domain are all points, all x, such that, what is the nature? Such that fx is greater than equals to 0. Means root fx function is defined for all x where fx is greater than equals to 0. Now case third. What is the domain of a function 1 upon root fx? Domain will be all values of x for which fx is only greater than 0. In this case, fx cannot be equals to 0 because in mathematics, if in denominator 0 comes, then system will does not exist. Now we have to take the examples for these three types. Let's consider fx is equals to 1 upon x plus 2. Then what is the domain? Domain will be all real number except minus 2, because at the minus 2 this fx is not defined. Now take one more example. Fx equals to under root 9 minus x square. What is the domain of this question? Domain will be all x such that 9 minus x square should be greater than equals to 0. Now it is inequality, and as we know, in inequality the coefficient of x must be positive, so it can be simplified like this: less than equals to 0. Sign of inequality will change. Now factorize it. X minus 3, x plus 3, less than equals to 0. Arrange the critical points on the number line in increasing order. 3, 3. A wave comes from this and goes to this side. This region is plus, this region is minus, and your answer will be minus region. Means x belongs to minus 3 to 3 will be the domain of this question. Now let's see one more example. Example number 3. Fx is equals to 1 upon under root 9 minus x square. Then what is the domain? Domain will be 9 minus x square greater than 0. Now we can say that the domain will be x belongs to open interval minus 3 to 3. What is the algebra of the function? Let f and g be the two functions and their domains are df and dg respectively. Then the sum, difference, product and quotients functions are defined as sum function f plus g of x is equals to fx plus gx for the common domain, means it is the df intersection dg. This is equals to df into dg. What is the difference of the function? F minus g of x is equal to fx minus gx for the common domain. Multiplication of two functions f into g of x is equal to fx into gx for the common domain, and f upon g is equal to fx upon gx for the common domain, means x belongs to df into dg except all the points, all the x such that gx equals to 0. This is the common, or you can say domain of f upon g function. Let fx is equal to x cube plus 1 and gx is equal to x plus 1, and we have to find f plus g, f minus g, f into g and f upon g. Suppose then what is the f plus g? F plus g of x is equal to fx plus gx. It will be x cube plus 1 plus x plus 1 is equal to x cube plus x plus 2. Now what is f minus g of x? It will be fx minus gx, means x cube plus 1 minus x plus 1. Now simplify it, it comes out x cube minus x. Now what is f into g of x? It will be fx into gx is equal to x cube plus 1 into x plus 1, and last f upon g of x is equals to fx upon gx. It will be x cube plus 1 upon x plus 1. Keep in mind x cannot be minus 1 here. This is called algebra of the function. Now we can solve some questions here. Domain of function log x square minus 9. As we know, log is defined for all positive numbers, means x square minus 9 mod should be greater than 0. Mod is always positive as we know, but at x equals to minus 3 and 3 it will be 0. So the domain of the function will be all real number except minus 3, 3. Option number 3rd is correct. C is correct. Question number 2, the domain of the function. This is the algebra of the function. In the function fx, two functions are in addition form, means the domain of the function is defined at the common points. What is the meaning of common points? X minus 1 should be greater than equals to 0 because this is a within a root function, and 6 minus x is also greater than equals to 0. Solve it, x greater than equals to 1, and for this system minus times x minus 6 should be greater than equals to 0. Now x minus 6 less than equals to 0. Your answer will be x less than equals to 6. What is the common answer? Here your answer will be 1 to infinite. Here your answer will be 6 to minus infinite. Means from 1 to infinite, from 6 to minus infinite. This is the common reason. Means the domain of fx will be x belongs to closed interval 1 to 6. What is the answer? Option B. Question number 3rd. The domain of the function. It is a function of the type within a root function, means 2 minus 2x minus x square should be greater than equals to 0. Now x square plus 2x minus 2 should be less than equals to 0. Now you can factorize it or simplify it, or by making the perfect square. It is x square plus 2x plus 1 minus 3 less than equals to 0. This is the perfect square, means it will be x plus 1 whole square less than equals to 3. Now simplify it. X plus 1 mod less than equals to root 3. Now solve it. X plus 1 lies between root 3 to minus root 3, means x lies between minus 1 minus root 3 to minus 1 plus root 3, means our answer will be option B. Students, now we will study method of determining range. As we know, what is the range? Range is the value of fx at the point of domain. Means to find out the range, first of all we have to find the domain. Got it? Suppose domain is the real number or real number minus some points. Then we can find the range by following methods. And method number 1 is here. Representing x in terms of y. This is the main heading. If y equals to fx, try to express x equals to gy, then domain of gy represent possible values of y, which is the range of fx. What is the meaning of this? Consider a function fx equals to this, and we have to find the range of this function. First of all, we have to find the domain. As we know, the domain is all the real number except denominator is equal to 0, means all the real number except x square plus x minus 1 equals to 0, means it is a real number. Now we have to follow some basic steps. Put y equals to fx. Now find value of x in terms of y. For that we have to cross multiply the system. It will be yx square plus yx minus y is equals to x square plus x plus 1. Now it will be x square y minus 1 plus x times y minus 1. It is minus y plus 1 is equal to 0. Now it is quadratic equation of x. As we know, x is real number, or you can say real number minus some points, means roots of this quadratic equation are real, means d is greater than equals to 0. What is the d? It is b square minus 4ac minus 4a into c. This will be greater than equals to 0. Now solve it. Y minus 1 square means y square plus 1 minus 2y minus 4 times y square minus 1 greater than equals to 0. It will be y square plus 1 plus 2y minus 4y square plus 4 greater than equals to 0. Simplify it. It is minus 3y square minus 3y square plus 2y plus 5 should be greater than equals to 0. Now it will be 3y square minus 2y minus 5 less than equals to 0. Factorize it. 3y square minus 5y plus 3y minus 5 less than equals to 0. Here y is common. 3y minus 5 plus 1 is common. 3y minus 5 less than equals to 0. Common factor is 3y minus 5 and y plus 1 less than equals to 0. On the number line, arrange the critical points. It is the minus 1. It is the 5 by 3. A wave comes and goes. Your answer will be minus 1 to 5 by 3. Means range of this function is minus 1 to 5 by 3. The value of function is from minus 1 to 5 by 3. This is the first method, or you can say method to find the range if domain is real number or real number minus some points. Now second method to find the range is the graphical method. You have to draw the graph of that function and then easily find the range, because the range is the value of fx, and as we know the fx is y and y comes on y axis. For example, you have to find the range of the function x square minus 4 upon x minus 2. If we simplify this, then it is x plus 2 x minus 2 upon x minus 2. One thing is important, the domain of this function will be all real number except 2, means at the point 2 this function is not defined. On the domain we can cut this point, means fx is equal to x plus 2 now. As we know, this is the straight line, and a straight line goes from minus infinite to infinite. Means range of fx is minus infinite to infinite, means r, except the point 4, because at x equals to 2 the value of fx is 4. f2 is 4, and as we know, we never be put x equals to 2 in the system because x equals to 2 is not lying in their domain. If we don't put x equals to 2, then how we can find the value of fx 4? That's why the range will be all real number except 4. Further, if fx happens to be continuous in the domain, then range of the fx is from minimum fx to maximum fx. However, for sectionally continuous function, range will be the union of minimum fx to max fx. Overall, those interval where fx is continuous, as shown by the following examples. Example first is for the continuous part. This function is continuous, that's why the range of this function will be from y1 to y2 closed interval. And for this graph, because it is the sectionally continuous graph, or you can say discontinuous graph, the range will be for this continuous section from y2 to y3. As we know, this is the lowest point, means from y2 to y3. Got it? Then next point is from y7 to y6, you can say here, and then y4 to y5. Union of these values of y will give the range of this graph. We can also find the range by using monotonicity. As we know, many of the functions are monotonic increasing or monotonic decreasing. In case of monotonic continuous function, the minimum and maximum value lies at the end points of domain. This is the most important part. Suppose there is a graph on x and y axis and it is the strictly increasing like this. Then it is the terminal ends. As we observing here, the range of the graph will be from FA to FB, you can say this point. This is the range of graph on the y-axis. This is the importance of the monotonic increasing or monotonic decreasing function. If we check the function, if it is monotonic increasing or decreasing, then we can easily find the range of the function. This is most important things which we can use after understanding the monotonicity of the function. So up to now we have studied how to find the range of the function. Range of the function, first of all we have to find the domain. If domain is real number, then method 1 can be used. Method number 2, we can draw the graph of the function, and by observing the continuous and discontinuous graph, we can find the range of the function. And method number 3, by using monotonicity, we can find the range of the function.